working with area. The area of the big triangle, and I want to find the area of just one of the small triangles, I divide the whole thing by 4 because each of those 4 triangles are the same value. So the next one is about perimeter. If the perimeter of BCD is 15, then we want the perimeter of ACE and triangle ABF. So the perimeter of BCD is this small triangle. How do we calculate the perimeter of the big triangle? Perimeter is the distance around, like I'm building a fence. Okay, I would add it all together. What would I add together? So the perimeter of the small one is 15. What about the perimeter of the big one? No, that's a different problem. The small triangle is 15. What do you know about all the little sides of the triangle if it's the smaller triangle compared to the big one?
All the little ones are 15.
Okay, all the little ones are 15. That's good. So looking back at the notes from Friday, let's look right at these notes where we talked about perimeter and area. Here's the perimeter of the big triangle. The big one was 40. Then we tried to find the perimeter of the small triangle and we had to divide by 2. Now we have the perimeter of the small triangle. Yes, Gabe? Times it by 2. Good. So what's the perimeter of the big one? What's 15 times 2? Okay. 30. All right. What about the perimeter of ABF? Triangle ABF is here. What's the perimeter of this triangle? That is 15 as well. All the little ones are 15. The big one is double. All right, area. The area of triangle BDF is 10 inches squared. What is the area of BCD plus the area of FDE? So the area of BDF is this little triangle. We want to add these 2 triangles' areas together. So what is the area of those 2 added together? Not 30, it's 20. How did you get 20? Added 10 plus 10. Good. The area of all of the little triangles is 10. So this area is 10 and this area is 10, giving us a total area of 20 inches squared. So things to remember about mid-segments. Perimeter. To find the perimeter of a little triangle, you divide the big perimeter by 2. Area is a 4th. All right, let's do some algebra. So 2 and 3 involve what your IXL is going to look like. So we need to solve for X, the measure of PR, and the measure of AJ. So to start, which segment name is our mid-segment? Or the letters or the numbers that correspond to it. Which one's our mid-segment? 3X is our mid-segment. So our formula is the mid-segment equals 1/2 of the parallel side. And in this case, our mid-segment is 3X. What value should we put inside of parentheses? What's our parallel side? 4X plus 20. So to start this problem, the first thing you have to do is actually write the equation. That's step 1, write the equation. Our parallel side, remember, is the side that the midsegment does not cross. Our parallel side is the side the midsegment does not go through. It's the parallel side to your triangle. The midsegment is the side that cuts through two other sides. So the midsegment intersects side AC and CJ. So this is the midsegment. The midsegment will always be inside of the triangle. The midsegment is always inside of the triangle. The parallel side is always outside of the triangle. It's the side of the triangle. And so the midsegment is inside. The parallel side is going to be one of the full sides of your triangle. Now, the math isn't going to change to solve these problems. The pattern will always be the same if you have variables. Right? Whenever you have the 1/2, right, you do not want to distribute the 1/2 because eventually you'll end up making decimals, and we don't want to deal with that. So our goal is to solve this problem by clearing the fraction. So when we get to trig, clearing the fraction is something you will do every single time. So we're going to practice now. So what makes a fraction exist is the denominator number, the number on the bottom. To get rid of a fraction, you have to get rid of the bottom number. A fraction is just division. So to move a fraction or to get rid of it, you do the opposite of division, which is what? Multiply. So the opposite of division is multiply. So what we're going to do is move the 2 to the other side. Okay? You always move the bottom number because to make a fraction go away, it's the bottom number that you have to move. So whatever the bottom number is, that's what you multiply. And in this case, it's always going to be a 2 because we're dealing with a half. So underneath, on both sides, we're going to multiply both of the sides by 2. You need to put parentheses around the 3x because if there's more stuff over there other than just 3x, if there's a binomial or a trinomial, you have to put parentheses around it because if you don't, you're going to forget to distribute to all of it. So the parentheses just groups everything together. Okay, you want to put it on the left and on the right because we're moving it. Okay. So on the left-hand side, you have to distribute to every term. So we've got 2 distributed into 3x. So 2 times 3, 6, and then the x just kind of follows along with it, so 6x. On the right-hand side, the whole purpose of multiplying by 2 is so that the 1/2 goes away. So on the right-hand side, the 2 on the bottom of the fraction and the 2 that I wrote in pink, those cancel because they're opposites. So this 2 and this 2 go away. We do not distribute the 2 into parentheses. The goal of what we just did was to move it. Now, the 1 gets distributed. So whatever's on top, you distribute in. Well, does it change inside of parentheses if I multiply everything by 1? No. So I don't really have to do anything. I just have to pay attention because if that number was a 3, I'd have to multiply 3 in there. So multiplying everything by 1, it doesn't do anything. So I'm just going to bring it down. So pay attention to the number in the top. If it's not a 1, you still have to distribute it. Now how do we solve from here? Okay, we want to move the 4. 6 minus 4, we get 2x equals 20. Then what? Okay, when we divide by 2, what's our x value? 10. All right, so x is 10. So up here, I'm going to put 10. Are we finished? No. How do we solve for the measurements of PR? Yeah, we've got to plug 10 into 3x. Remember, when it wants to know what PR equals, it wants a distance you can find on a ruler. I can't find 3x on a ruler. So whenever it says PR, we're not putting 3x. We're taking x and subbing it in. So this is 3 times 10, or 30. Remember, anytime you are finishing a problem by substitution, you have to simplify it. So 3x isn't our answer, 30 is. That's why we use 10. All right. What's the length of AJ? $60. Remember, to help you, you could also know that if this is 30 to go out, I would multiply by 2. So this would have to default to 60. You could do it that way. Or you could substitute. So 4 times 10, not 4 times 100. 4 times 10 plus 20 is 60. All right, take a second. Look over this question. Number 2, what can I clarify? Any algebra stuff, setup, moving the half? Is there anything that you're not sure why I did something or something is confusing you? Okay, try number 3. So just set it up. What, did you have a question? Are you sure? Okay, so try number 3. So set it up. And just set up number 3, see how far we can get. Okay, so mid-segment equals half the parallel side. Make sure that you start with the words first. Okay. That way you remember the formula. So what should we replace mid-segment with? What's our mid-segment measure? 2x. Then our equals 1/2 with the parenthesis. That's just part of the problem. It's part of the formula. What goes in parentheses? Yes, 10x minus 21. That is our parallel side. So remember, the mid-segment is always inside of the triangle. The mid-segment's always inside. The parallel side is always that side of the actual big triangle. So the mid-segment's inside. The parallel side is the side that it doesn't cross. So you're going to substitute, which we did. How do we clear that fraction? Because I don't want to distribute it. By? Yes, multiply by 2 on both sides. So remember, whatever's on the bottom, that's what you multiply. In this case, it's always going to be a 2 because it's half. It's always a 2 because it's half. So on the left-hand side, 2 times 2 is 4. So when you multiply in, 2 times 2 is 4, so we get 4x. What happens to the 2's over on the right-hand side? Yeah, they cancel. So this 2 and this 2 cancel. What do I do with this 1? Okay, what should I do with it? Okay, I could bring it down or I could just distribute it in. Does it make a difference though? No, because it's a 1. 1 times anything is just itself. So if I'm paying attention to that 1, I should know that this doesn't change. So it's just 10x minus 21. Remember, it's just good math practice to pay attention to whatever is on top because we have to distribute it in. But a 1 is not going to make much of a difference. This is where some of us got a little stuck. What should we do next? Okay, move the 10. Now, don't move the 4 because if you move the 4x, you end up with nothing on the left-hand side. I don't want nothing. I need a number. So I'm going to move the 10x by subtracting it. Four minus 10 is negative 6. And I bring down my negative 21. Another thing that we sometimes forget is our negative signs. If you don't bring down the negative, it changes your answer. So we have to bring down our negative 21. Now we should be dividing by negative 6. So we should still get a positive answer. So what is our x value? 3.5. Decimals are okay to get. Decimals are just numbers. What's the length of AP? 7. AP's measurement is 2x. So 2 times 3.5 is 7. What about CD? That one is 14. So you can do 10 times 3.5 minus 21 to get 14. Or if you know the mid-segment is 7, how can we find CD without really doing any math? Yeah, multiply by 2. We're going out. We multiply by 2, so this has to equal 14. 7 times 2. So you can plug it in, or you can multiply by 2. Do we need to talk about any kind of substituting or anything like that? Remember, you can do it all in your calculator. So if you're not sure how I got those answers, I'm just taking X and I'm plugging it in. There we go. So I'm just doing, for this one, I would do 10 times 3.5 minus 21. And it'll give you 14, okay? So you can do it all on your calculator, just make sure that you're typing it in with parentheses. The IXL that we're going to do today is going to focus on the algebraic side of mid-segments. So before we start those, we're going to talk real quick about how to determine if something is a mid-segment. Okay? So down at the bottom, we have to determine if we have enough information to determine if AR is a mid-segment. Okay. So right here on number 6, add this additional information to your problem. So add additional information that AR is 20 meters and CD is 40. So we're just adding that a little bit of additional information to do this problem. Okay. So our job is to determine whether or not the information provided in each of the separate problems is enough to determine if AR is the mid-segment of the triangle. So each of these problems are individual. Okay. So let's start with the first one. The measurement of AR is 10, and the measurement of CD is 20. Does that make AR a mid-segment? Yes. How do you know? Okay, 10 times 2 is 20, so it's half the measurement. So 4 is yes. That's enough information to determine if it's a mid-segment. What about number 5? A is the midpoint of CB.
Probably not.
Why do you think probably not? Okay, it does tell you A is the midpoint, but you are correct. That's not enough information, but why is it not enough information?
It says midpoint, not circle point.
Okay, well, it does say A is the midpoint. So it's focused right here. It says that A is the midpoint of CB. That's not enough information to tell me it's a mid-segment, but why? Okay. The mid-segment has to go through how many midpoints?
3.
No, not 3. It's got to go through 2.
You got that extra line for triangle.
Okay, we only know A is a midpoint. What other point has to be a midpoint? R has to be a midpoint. Does it tell me R is a midpoint? No, that's why it's not enough information. So for it to be a mid-segment, it has to go through both midpoints. For it to go through one midpoint, I could draw and connect it down here somewhere. It's got to go through both. So 5 is not enough information because I need 2 midpoints. That's the definition of mid-segment, is it goes through 2 midpoints. All right. Number 6. The slope of AR is 3 over 4, and the slope of CD is 3 over 4, as well as AR being 20 and CD being 40. Is that enough information? Slope of this line here is 3 over 4, and the slope of this line here is 3 over 4. And AR is 20 and CD is 30. Haley, what do you say? Haley says yes.
Things kind of laggy.
Yeah, I know. It's because I'm recording it. So the slopes of my sides, they're identical, which makes them what? What kind of lines have identical slopes? Parallel lines, so they're parallel, and they're also path measurements. So yes, that is enough information to determine if it is a midsegment. What about number 7? A is the midpoint of CB, and R is the midpoint of BD. You sure? How many midpoints should we have? We need 2, so it says A is a midpoint and R is a midpoint. Yeah, that one is true. So it's kind of like number 5, but we've added that additional midpoint in. So this one does work. We've got 2 midpoints. All right. CD is 15 and AR is 20. No, that's definitely not true. Why is this one no? What? Yes, 15 times 2 is not 20. 15 times 2 is 30, so it's definitely not a midpoint. All right, number 9, the slope of CD is 2 over 7, and the slope of AR is 2 over 5. No, why is that a no? Okay, so they have to be the same measurement, and these are not the same slope. So this is no. So this is just kind of a review. This is how the EOC is pretty much going to quiz you on this stuff. It's going to take information about theorems and just put them in words, where you have to determine yes or no if it's enough information, okay? Your IXL for today is 8GT, which will focus on algebra. So I'm going to pull this down. These are the problems that you're going to have on your IXL. The code is 8GT, and I made you it now. So yeah, I'll show you how to get them.